our math analyzers. Welcome to your Chapter 10, Lesson 2 notes, all about the amplitude of your sinusoidal graphs. Before we start to move our sine and our cosine functions around our coordinate planes for them, before we start to do that, I think it's important to kind of review what transformations of our functions look like in general. Okay, so moving up, down, left, right, widening or narrowing our functions, flipping them upside down, little things like that. And I think one of the best functions to look at that with is the absolute value function. So if I start with you from the basic absolute value function, f of x equals the absolute value of x, which is right here in your all favorite color, purple, the trash color that it is. This is where we're starting at a coordinate of 0, 0 for its vertex, a slope of 1 if we're looking to the right, so up 1, right 1, okay, which is the equivalent to amplitude when we get there, right? And then what we do with this, knowing the coordinates of the vertex, 0, 0, and a slope of 1, the number in front, how much we're going up and right. What we do is then put that into the full form of the function, and that's where we simplify down to just the absolute value of x. If I place all that into the full form of the function, I get f of x equals 1 times the absolute value of x minus 0 in parentheses plus 0 at the end. Or excuse me, an absolute value of ours plus 0 at the end. And so we've looked at this before and said, oh, yeah, well, this is just all of those pieces, those basic pieces, and we don't have to write in zeros here, and we don't have to write in a 1 up here. Excuse me. So now let's look at those equation changes that actually flip it upside down. Well, that's a negative 1 as a slope. So now to the right of the vertex, you're actually down 1 and right 1. So that's why we're flipped this direction. If we throw a 3 in front of the absolute value bars, the slope is now up 3, right 1, up 3, right 1. That's the narrowing. And if we throw numbers inside and outside, well, now that takes our vertex and brings it to the left, 1, 2, 3, and down 1, 2. It's always the opposite sign of what's inside the absolute value bars, or the parentheses if you have them. And it's the same sign of what's outside for the up and down. So here's your left and right. Here's your up and down. Here's your widening and narrowing, as well as your flip upside down. So in the equation, we can see all those pieces making those changes. Well, our plan is to now do that with our sine and cosine functions. We call those the sinusoidal graphs, okay? Because they're so similar, we actually just have that name for both, that covers both graphs. So if I'm talking about a sinusoidal graph, I might be talking about a sine function, I might be talking about a cosine function, and we'll use the graph itself to determine which I am speaking about. Okay, so the basic vocab that we are going to need for our sinusoidal functions is right here. Okay, just said that, right? Our sine and cosine functions are considered our sinusoidal graphs, right? Each of these has an amplitude, a period, a phase shift, also known as a horizontal shift, and a vertical shift, and a midline. And what we do is we use those pieces to build its equation, or we use its equation to determine those pieces. So one direction or the other, that's how we put this together. Okay, so let's just go over all the vocab first, and then each of the next few lessons goes through these things one step at a time. So the amplitude is the half the distance from the maximum to the minimum divided by 2. It's half that total distance between the top and the bottom. Okay? That's the amplitude. And we do always write our amplitude as the positive version. So that's why over here it's the absolute value of A. The period is also just the cycle that it takes to get one full curve. Okay, so we call it period, but it really is the entire curve of the graph. What does that fit over? Okay, it's the horizontal length of one repeating pattern of the function. And we have the general idea of each of the functions, so we can look at our graph and say, oh, sine usually starts here and ends here, so one full period is from here to here. Okay, that's what we use for that. And there is a specific method that we'll use. Of course, we are typically using radians now, and I know that's tough, but we know the conversion, so we'll be able to deal with that. But 2 pi is a total circle worth of radians. So in the equation, we take 2 pi and divide it by this value out here, b, and that's how we figure out what one period of our graph is. Sometimes we call the horizontal shifts a phase shift, but it's the horizontal distance that your graph is moving, right? So it's if your graph moves left and right. All right, that's the phase shift, and that's the C in our equations. And then a vertical shift is the up and down. And that's the D at the end of our equations. And that makes sense. That's just like with absolute value, right? This number out front was the slope. This number in here helped us determine left or right. This number out here helped us determine up or down. The added bonus is this B value right here, that because we're looking at something that is on an infinite cycle, because it's coming from a circle that is infinitely round and round and round, because that's what we're looking at now for our function pattern, there's this period or cycle that is also a part of what we need to figure out. Okay, now that period is also sometimes called a frequency. So I just want you to notice that here it's being referenced as frequency, and here it's being referenced as period. And in that specific lesson, I will go through when I use each of those words, because they do slightly have a difference. And I will talk about that when I do that specific lesson. Just looking at it, it does sound like a lot of this is hard, but remember, we're going to take this one step at a time. Okay. And today we're just focusing on amplitude. And amplitude is probably the easiest of all of them, so it's a great place to start. Okay. So this is a picture of our most basic sine function. And I do know that this is my most basic sine function, because if I kind of just look from 0 to 2 pi, here to here, we can see kind of a sideways S, right? That's my most basic sine function. Right now, this is an amplitude of 1. And how do I know that? Because its maximum is at 1, its minimum is at -1. And if I counted from the max down to the min, 2 places, I take half of that, that's its amplitude. Because the amplitude is from the midline to the maximum. This is considered the amplitude. Okay, that's considered the amplitude from the minimum to the maximum. From the midline to the maximum. Okay. Now, an amplitude of 3 would mean that its maximum is now all the way up to 3, and its minimum is now all the way down to -3. So changing it to an amplitude of 3 on the same axis would mean that the curves are just higher and lower. So what I'll do is at pi over 2, where my maximum usually is, I'll go all the way up to 3 with it. And at And at 3 pi over 2, where my minimum would usually be, I'll go all the way down to -3 with it. Okay? Now I'm just going from 0 to 2 pi for now. I'll head backwards in a second. But now I am just going to connect. And the 0, notice, stays the same because 0 times 3 is still 0. And there we go. A little off on that end. There we go. That's our amplitude of 3. So let's just head backwards with that. This minimum would now just go down to -3. This maximum would now just go up to +3. And let's head backwards with that. 0 is still here at -pi. Do try to curve. I was just a little lazy with my curve just then. There we go. That has an amplitude of 3. So let me just show you with the count. Okay, over on this side, because I did the amplitude here. All right, so over on this side, I'm just going to show you with the count. Down 1, 2, 3. This is the amplitude. Okay, that's the amplitude of 3. What does this mean for the equation of the graph? Well, if the amplitude is the number that's in front of our sine function in the equation of the graph, then all I have to do is take the original sine function and put a 3 in front of my sine theta. And that's it. That's the new equation of the graph. Okay? 3 is the amplitude because it's the number that is in the front, indicating an amplitude of 3. The height, the maximum, it's up 3. The minimum, down 3. Now, I also mentioned, and I mentioned it very casually, but I also mentioned when I was looking at this problem, something called the midline. And the midline is just if you cut the graph in half, what is that horizontal line that cuts the graph in half? And the midline in this case is, of course, what we consider to be our x-axis here. This is the midline, right? It's a y equals 0. But I just want to point out that the amplitude is always how far up and how far down are we from the midline. And the midline is usually something to kind of easily eyeball. If you can't easily eyeball it, what you can do is just count from a max point down to where a minimum point is and divide it by 2. So 1, 2, 3, 4, 5, 6. From a maximum to a minimum is 6 places. And 6 divided by 2 is 3. So if I count back in 1, 2, 3, there is my midline. And whatever that value is for y, that's going to be your equation of your midline. Okay? I just wanted to make sure you can see all of those pieces put together. Let me zoom back out. Now I've got exercise 2 and over here. And I can tell before I even get real into number 2 that this is a basic cosine function. And the reason I can tell that is because from 0 to 2 pi, we are starting high, middle is low, ending high. It's kind of the cup that cosine causes. Okay? So then I read to the left is a cosine function. Cool. What's the amplitude of this function? What is the equation of the midline of this function? Okay, well, let's take a peek. Let's count all the way up and down. So my y-axis is not labeled, but I can tell you we're going by ones for our y-axis. So if I go from my maximum and count down to my minimum, I get 1, 2, 3, 4, 5, 6. And 6 divided by 2 is 3. So if I count in 1, 2, 3, here is my midline. Notice my midline, kind of like an axis of symmetry. It is an axis of symmetry, but it is a dotted line, okay? So here's my midline, and it's y equals 0 again, And then we said that our amplitude is the distance from the max to the midline. You could even say the minimum to the midline, either one, right? So max to midline, 1, 2, 3. That means that my amplitude is 3. Okay? That's what that means. And again, you could count that from here to here as well. It's the same deal. And remember, you can also find that by counting from the maximum to the minimum and dividing by 2. 6 divided by 2 is 3. That's where we can get that amplitude of 3. Okay? What is the amplitude of this function? We just said 3. And what's the equation of this, of the midline? I want the equation of the whole graph. So I've got the equation of the midline. I've got the amplitude. Let's also state the equation of the entire graph. Remember that the amplitude is just going in front of the type of function we have, which is cosine. So 3 cosine theta is our equation. Okay? It's not too bad. One of the things I kind of like about these is it's actually easier to graph first and then state my points along the way when it comes to sine and cosine functions, which is a little backwards from what we typically do. But it really is. It's easier to actually graph this thing first. Okay? So I'm going to show you how to do that. And then I'm going to show you how to pick the points out from it. Before I even start graphing it, let's just review what each of these degree measures is in radians. So of course, 0 degrees is 0 radians. 45 degrees is pi over 4. 90 degrees, pi over 2. 135 is 3 pi over 4. 180 is pi radians. That's, remember, our semicircle. Then we've got, this is 5 pi over 4. Then we get down to 3 pi over 2. Then 315 is 7 pi over 4. And all the way up to 360, well, that's our 2 pi. Okay, so this is essentially our usual period, right? It's usually the distance from the beginning of the circle to the end of the circle, which is why when we then spread out our functions, it's the beginning of the function to the end of the function when we've unraveled them. All right, so again, I'm not going to fill these in as where cosine is at each of these spots until after I graph it. And what I'm supposed to graph this time is y equals -4 of sine theta. So for the first time, I have an amplitude that has a negative in front of it. Now let me just remind you that a negative flips the graph upside down. So how does a sine curve usually look? It usually goes up first and then back to the middle and then down. If you have a negative, what that means is you still start at 0, but you go down first and then back to the middle and then up. So it's just the opposite as far as how you start. Okay, but also remember that the amplitude is the absolute value of that number. It doesn't matter if this number is positive or negative, the maximum is still only 4 away from the midline. Okay, so since this is -4, I know that my maximum height will still be 4. Okay, that's what we're looking at here. So when I get to my height, my maximum height, it's still going to be 4. So that does mean that if I just go by ones on my graph, the top and bottom are 4 and -4 respectively. So if you're going by that, okay? So we'll do that. We do know that sine starts at 0, 0. And then since we're going negative, right? So this is a negative a, we have to start down. So we also know that sine will come back to 0, 0 at pi. So that means that at pi over 2, we are all the way down to -4 from the start. Okay? Now, what this means is we've come back. So we had down, we come back in our curve. Now we're going to head up. That means that our maximum height of 4 is going to come at 3 pi over 2, or 270 degrees. And then, of course, back down to 0. Now, I haven't mentioned it yet, but the midline here must be y equals 0 again. And that will continue to make sense for us because, well, we haven't moved our graph up and down yet. So since we're only stretching our graph as far as the amplitude goes, since that's all we're doing so far, not taking our graph and just moving it up and down, our midline is not going to be moving yet. Okay, so that's kind of a neat thing that's part of this, is the midline is still going to be that y equals 0. Now what I'll do is I will just connect. Okay. This is a nice stretch, right? And up and back down. Nice stretch out of our cosine curve upside down. This is the upside down version of our cosine curve. Okay, let's now take that backwards, right? Let's take that backwards. This guy's going to be way up, back to 0 in the middle. This guy's going to be way down, back to 0 in the middle. Okay, so if it helps to do one way versus the other, that's totally fine. I know sometimes I can graph better from one direction, but you want to try and get that curve continuous, and that is a very tough thing. Okay. So now I'm going to fill in our basic points, and then I'll go through and do your 45s for you and show you exactly what to do there. Okay. So our very basic points, of course, 0, 0, right? So that's our y value is 0. Then we get to pi over 2, so that's 90 degrees. Notice that's when we're all the way down to this negative 4. Okay. Back up to pi, we had come back to 0. Way up at 3 pi over 2 gives me my positive 4. And remember, that's normally our negative, right? So it makes sense that this is normally our positive, this is normally our negative. Those are opposites right now. And then back down to 0 here. Okay. Well, what do we always know about our 45s? Well, our 45s, sine or cosine, are always radical 2 over 2. And what did we know about these? Well, each of these points was multiplied by the amplitude of negative 4. So it stands to reason that actually I just need to multiply this by negative 4, and that will get me those interim points. And when I multiply something, I multiply in the numerator. So what this ends up giving me is negative 4 radical 2 over 2. And I know that negative 4 is evenly divisible by 2. So I end up getting negative 2 over radical 2 is my 45 point. And again, because I multiplied by negative 4, what I'm saying here is this negative radical 2 over 2 is for the quadrants that would typically be positive for sine. And it'll be the opposite for the quadrants that would typically be negative for sine. So actually, for all of these, it'll be negative 2 radical 2 for 45 and 135 respectively, which is pi over 4 and 3 pi over 4. So here and here that we know are usually quadrants 1 and 2, or are quadrants 1 and 2, and are usually the positive for sine. But because we had a negative amplitude, we just start down and head up. And that just means that over here, these guys are both positive 2 radical 2. Again, because that's where we are here. And it's lucky and it's wonderful. And this is why we go by those special right triangles specifically for these coordinates, is we get to find these values that are pretty much the same, right? Cyclical. There's a reason for that. There's a reason that we call it that. And so let me just show you that I can double check this in my graphing calculator. So just real quick, I checked to make sure I was in degree mode. Okay. And what I'm going to do is I'm just going to type in negative 4 sine of 45. Okay. And what we should be getting out is -2 radical 2 as a value. Okay, unsure, let's check. So -2 radical 2 is, there we go. Let's just double check another one. Let's double check 270. So -4 sine of 270 is, what did we have? There we go. Okay, so let's just do another one. 315, right? -4 sine 315 is positive radical 2 over 2. Neat how that all comes together, right? All that radical work we had to do, all that conversion of degrees and radians, all the unit circle stuff we had to remember, all the special right triangle stuff, it's all here. So just real quick, these are much enlarged pictures, which is why we're a little fuzzy here, but just showing you the difference between having an amplitude of a whole number and having an amplitude of a fraction. Same thing that you would expect in any other type of function. A whole number, of course, makes it much larger than the normal, black being the normal one, regular sine function. And half of that makes it smaller. Okay, so wider, right? Narrower for whole number, wider for fraction. Same as with with our quadratic function, same as with our absolute value functions. It's the same deal, right? That's the nature of how these functions move. These pieces are still the same. Now we're just applying them to the cyclical pattern of sine and cosine. Okay, so same with cosine, what that difference looks like. Okay? All right, so let's start with amplitude. We'll move around with amplitude and we'll state the equations of some of our functions with amplitude. And again, this has been your Chapter 10 Lesson 2 notes on the amplitude of our sinusoidal graphs. If you need help with this, good luck. I'm here for you. I'll see you soon. Bye, guys.